Hello friends, myself Dr. V.R. Dangar, MBM Science and Home Science College, Rajkot. Today we discuss about CO molecules MO diagram. So what is MO diagram of CO molecule and compare its stability with CO plus 1 molecule ion. Now let's see what is configuration of carbon monoxide CO atom. Here carbon Z is equal to 6, 1s2, 2s2, 2p2, and oxygen Z is equal to 8, 1s2, 2s2, 2p4. Here CO molecule is also heteronuclear diatomic molecule. The electronic configuration of carbon and oxygen atoms are 1s2, 2s2, 2p2, and oxygens 1s2, 2s2, 2p4. Therefore, in CO molecule, there will be 14 electrons. There will be 14 electrons. Now let's see what is MO diagram. How we can draw the MO diagram. Here carbon and oxygen. Here CO carbon atomic orbital, oxygen atomic orbital, and CO molecular orbitals are formed. Here carbon is 1s2, 2s2, 2p2. Here 2p2, not 2p3, 4 by mistake. Here one more electrons are filled here, but only 2 electrons are here. So oxygens 1s2, 2s2 and 2p4. Total number of electrons here 2, 2, 4, 6, 8, 10, 12 and 14 electrons. So total 14 electrons accommodate in CO molecules. Now let's see how many electrons in BMO total and total number of electrons in ABMO. Here 2 plus 2, 4, 6, 8, 10. Total 10 electrons are in BMO, bonding molecular orbital, and 2 plus 2, 4. Total 4 electrons are in ABMO. So now let's see what is bond order and order of energy. Now order of energy, sigma 1s is less than sigma star 1s, is less than sigma 2s, is less than sigma star 2s, is less than sigma 2px, is less than pi 2py is equal to pi 2pz, is less than pi star 2py is equal to pi star 2pz, is less than sigma star 2px. Now molecular electronic configuration of CO molecule. So COMO is equal to sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2px2, pi 2py2, pi 2pz2, pi star 2pz0, pi star 2pz0 and sigma star 2pz. Here all stars MO are ABMO and without stars are BMO. So now let's calculate what is bond order. Bond order is equal to 1 half NB minus NA, where NB is equal to number of electrons in BMO and NA is equal to number of electrons in ABMO. So bond order is equal to here total number of electrons in BMO are 10 and 4 electrons are in ABMO. Therefore 10 minus 4 is equal to 6. 6 by 2 is equal to 3. Thus, the value of bond order 3 indicates that there is a triple bond between carbon and oxygen atom. It is C triple bond O. What is magnetic properties of CO molecule? Moreover, as all the electrons in MO of CO molecules are paired, therefore it is diamagnetic in nature. Let's discuss about CO plus 1 molecule ion. When one electron is removed from pi 2pz MO of CO molecule, we can get CO plus 1 molecule ion. Molecular electronic configuration of CO plus 1 ion. Here CO plus 1 MO is equal to sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2px2, pi 2py2 is equal to pi 2p z1, pi star 2py0 is equal to pi star 2pz0. and sigma star 2px 0. Now let's calculate bond order of CO plus 1 molecule ion. Here bond order is equal to 1 half NB minus NA. So how many electrons are in BMO? 9 electrons in BMO and 4 electrons in ABMO. So 9 minus 4 is equal to 5 by 2 is equal to 2.5. Therefore in NO molecule there is 2.5 bond order value. Now what is magnetic property of NO CO plus 1 molecule ion? The magnetic properties of CO plus molecule ion, the presence of one unpaired electrons in pi 2pz. MO of CO molecule ion, it is paramagnetic in nature. Therefore mu is equal to under root n plus 2 bm, where mu is equal to magnetic momentum and n is equal to number of unpaired electrons. So n is equal to 1 and under root n is equal to, put the value of n is equal to 1 here, so under root 3. So under root 3's value is equal to 1.73 Bohr magneto. Now what is stability order of CO and CO plus 1? CO molecule, so bond order is 3, is more stable due to higher bond order value than the CO plus 1 molecule ion. CO plus 1 molecule ions bond order is 2.5. So here stability order CO molecule is more stable than CO plus 1 molecule ion. Now let's discuss about last heteronuclear diatomic molecule here, CO2, carbon dioxide molecules. Now MO, molecular orbital energy level diagram of CO2 molecule. Structure of CO2, carbon dioxide, or hybridization in CO2. So let's see what is hybridization in CO2 molecule. Here electronic configuration of CO2, central atom here carbon, Z is equal to 4, in ground state of carbon atoms valence shell, electronic configuration here helium is equal to carbon helium 2s2 2p4, total 6 electrons in valence shell of carbon. Here helium inert gas, so it take not part in hybridization. So here helium is NBMO. So here 2s2 2p2. So how many electrons are in valence shell of carbon or central atom? So here 4 electrons in carbon ground state, here 2s2 and 2p4. In ground state there are 2 unpaired electrons and 1 paired electrons. Now let's, by gaining some energy, carbon atom in transition atom, 1 electron of 2s orbital will be promoted to, goes to 2pz vacant orbital. Now there are 4 unpaired electrons are available in transition state of carbon. So what is hybridization? So now in CO2 molecule here 2 oxygens are combined or attached to this carbon atom by 2 sigma bond and 2 pi bond. So pi bond does not determine the geometry of any specific molecule. Its pi electron density surrounded to bond axis. Therefore pi bond is negligible from hybridization. So here what is hybridization? Here sp hybridization. So CO2 molecule is linear due to sp hybridization, which involves 2 sigma bonds and 2 pi bonds. Its MO diagrams are given as below. Here carbon atoms and here 2 oxygen atoms, atomic orbitals. So here it's here non NB MO, lone pair of electrons, here 2 oxygens atom and here 1s and 1s, how to combination. So here increase carbon and oxygen's electron negativity will be different. Carbon's is less electronegativity than oxygen atom. Therefore increase in nuclear charge, decrease the energy of atomic orbitals. Therefore, the atomic orbitals of oxygen atom lies lower than that of the carbon atom. So its MO diagram, we can see this type of diagram. Now let's, what is bond order and magnetic properties of carbon dioxide. Here 1s and 1p, it is 2 sp hybrids of carbon atom combined with appropriate 2p orbitals of each oxygen atom to give 2 sigma MOs, and consequently 2 sigma bond as well as 2 sigma star MOs. 2px and 2py of carbon atom will combine with 2p orbital of oxygen atom to give the 2 pi bonding and 2 pi star anti-bonding of equivalent energy. Remaining fully 2p orbitals on each oxygen atom will remain as non-bonding MOs having lone pair of electrons like 2s on the same atom. Thus, ground state electronic configuration of molecular orbital of CO2 will be as follow. So here electronic configuration, molecular electronic configuration of CO2 molecule, its bond order is equal to, we can calculate here sigma bonding to sigma bonding B1 to B2 to pi to By is equal to pi to Bz, and here vacant orbital. So what is bond order of CO2 molecule here? Bond order is equal to 1 of Nb minus Na, where Nb is equal to number of electrons in BMO and Na is equal to number of electrons in ABMO. So bond order is equal to 1 half in total number of electrons in BMO are 8 and ABMO 0. So 8 by 2 is equal to 4. So bond order in CO2 molecule is 4, in which 2 are formed by sp-sp overlapping and the others are formed by pi orbitals overlapping. Here linear shape of CO2 molecular, 2 sigma bond and 2 pi bond. Now let's, what is difference between bonding and anti-bonding molecular orbital, BMO and ABMO. Distinguish BMO and ABMO. So what is BMO, or what is bonding molecular, or what is ABMO or anti-bonding molecular orbital? So here these are differences of BMO and ABMO. First off, let's see what is BMO. It is formed by addition overlap of atomic orbitals, while in ABMO it is formed by subtraction overlap of atomic orbitals. The wave function of bonding MOs is given by psi MO is equal to psi A plus psi B. In ABMO, the wave function of anti-bonding MOs is given by psi star MO is equal to psi A minus psi B. In BMO, it is formation takes place when the lobes of atomic orbitals have same signs. In ABMO, its formation takes place when the lobes of atomic orbitals have different signs. The energy of BMO is lower than that of the atomic orbitals from which it is formed. In ABMO, the energy of antibonding MOs is higher than that of atomic orbitals from which it is formed. The electron density is high in region between the nuclei of bonded atoms in BMO, but in ABMO the electron density is low in the region between the nuclei of bonded atoms. And last difference, every electron in BMO contribute toward the attractive force. In ABMO, every electron in antibonding contributes toward repulsive forces. Now last topic, now what is comparison of Vbt and Mot. So let's comparison of Vbt and Mot, valence bond theory and molecular orbital theory. Here similarities and dissimilarity also we can discuss about Vbt and Mot. So first off, what is similarities of Vbt and Obt? Both the theories, means Vbt and Mot, are good attempt to explain the formation of covalent bond and widely accepted. According to both theories, the overlapping of atomic orbitals should have similar symmetry and energy. Both the theories explain that because of covalent bond formation, the electron charge density increase between two nuclei. And last similarity, both the theories indicates the directional properties of covalent bond. Now, what is this similarity, or what is comparison of Vbt and Mot? So, Vbt considered bonds as localized between one pair of atoms. In Mot, considers electrons delocalized throughout the entire molecule. In Vbt, creates bonds from overlap of atomic orbitals, for example SPD, and hybrid orbitals sp, sp2, sp3 forms a sigma or pi bond. In Mot, combines atomic orbitals to form molecular orbitals sigma, sigma star, pi and pi star, and create bonding and antibonding interaction based on which orbitals are filled. In Vbt, predicts molecular shape based on the number of region of electron density, and in Mot, predicts the arrangement of electrons in molecule. And last difference, needs multiple structure to describe resonance in Vbt, but no need multiple structure to describe resonance in molecular orbital theory. Thanks.